Hey everyone, we're going to be finding the domain of a composition of functions today. This is Nicholas JMV. So we got one example and we're going to do two parts though to that example. So here's our example. We have this function, let f of x be x squared minus 1 and g of x be the square root of x. Find the domain of the compositions. So what you actually have to do first is find those compositions. So we're going to look at g of f first. Okay. So when we write this, if we look at it, g of f, okay, well, Goff, okay, excuse me, I should say g composed with f, okay, is going to look like g of f of x. That's what it looks like. That's what this is saying. That's equivalent. So what we want to do now is look at g of, well, we know what f of x is. We've already talked about it. It's x squared minus 1. We got that from up here. F of x equals x, so it's just a direct substitution here. Now I know that the g is the square root of x, so the idea here is wherever you see an x and g, you're replacing it with x squared minus 1. Thankfully there's only one x value, so it just becomes x squared minus 1. Now we've got the composition, so what you can do now is actually find the domain. To find the domain, so the domain of the composition, okay, to find it we have to say, well, it's a square root. The square root, whatever's underneath, has to be greater than or equal to 0. It's a square root. So there we go. We put the number underneath, the radicand, and we set it greater than or equal to 0. And we're going to solve now for x. And you do that, and you have x squared is greater than or equal to 1. Square root both sides, you get x is greater than or equal to plus or minus 1. Now, when you write that, the domain is going to be from negative infinity to negative 1. We can include negative 1 because you can take the square root of 0, so this time you can include it. And that's going to be in union with 1 to infinity. Now, you might be thinking, what about negative 1 to 1? Why not in the middle, in between? Well, if we try 0, which is between negative 1 and 1, you get the square root of negative 1. So that doesn't work. So the numbers between negative 1 and 1 do not work. So this is your actual domain. Now, when we're looking at this second example, f of g of, we're going to be looking at f of g. Now, just because they look like they're commutative doesn't mean they're going to have the same domain. So we have f of g of x, okay? So that's going to be f of g. So g, remember, is square root of x. And so now, remember, we have to compose the function first. So f was x squared minus 1. So you're going to have the square root of x squared minus 1, which ends up being x minus 1, okay? Now, you might say this is linear, so the domain is all real numbers, okay? However, if you look back at the original, g can't be all real numbers. G has to be greater than or equal to 0 here. So you can't just say, well, this is a line, so the domain is all real numbers. This original g of x had a restriction. So the domain here of f of g is actually just from 0 to infinity. Okay, so that's how you find the domain of a composition. If you have any questions or comments, go ahead and type them below, and we'll see you next time.